Good morning, Year 4, and welcome to your Friday maths lesson. So we're going to carry on with some work on translation from yesterday. But first of all, I want you to do your 5-a-day. So hopefully you have got it ready, or if not, I'm about to bring it up on the screen for you, and we can have a look together. So let me find my PDF. Here we go. Right, so you should be able to see on your screen the 5-a-day. Right, okay. So pause it here, do the 5 answers in your book, and then we will come back to answering the questions. And whilst you do that, I'm just going to grab my pen. Right then, my lovelies, I hope that you've managed to answer the questions, and I'm just going to go through the answers with you. So, name a factor pair of 24. Well, you did factor pairs on Wednesday in the live lesson with me, so hopefully you can remember the method that we did. So you start at 1, so 1 and 24. Then we would go through, so you could have that, so that's a tick. We'd go to 2, so 2 and 12. So if you've chosen that one, you've got a tick. Or if you did the inverse, if you put 24 and 1, that would still be correct. Or if you did 12 and 2, that would still be right. So, oh, I'm just looking at the light. It's not very... I think it's the sunshine coming through. If you did 3 and 8, is it in the 4? 4 and 6, so they would both be right. Again, if you swap them over, 8 and 3, or 6 and 4, because remember, they are the same factor pairs, you've just switched the numbers around. Is it in the 5 times table? No, it's not. And then if we get to the 6 times table, we can see that we're repeating. So there are 4 factor pairs for 24. So any one of those, and you would have got that right. Now, question 2 was, you can see it now, can you write the Roman numeral for 47? So we did that this week as well. I'm just going to write the other questions down on the board as well. And then that way we can go through 2 questions at once. So I'm going to stop sharing my screen. So the Roman numeral for 47. Can you remember how we wrote those? 47. So 40 was that funny one, isn't it? So it's 10 less than 50. And then 7, which is 5 and 2. So 47. All right. And then just move the camera so that you can see. So 105 times 0, well, we know the rule for that. Anything times 0 is 0. Something times 1 gives 675. Well, we know that a number multiplied by 1 always gives the same answer. And then something times by 322 gives 0. Well, we've said it there, haven't we? The answer is 0. Now, the 2 shapes that you could see in the 5-a-day, bring that back up. There we go. Share my screen. So the 2 shapes that you could see, we have got a parallelogram and we have got a 3D shape, which we'll be looking at after half term, and we have a cube. All right, so I'm going to just switch then to my date and Walt. And if you want to pause it, you can do the date and Walt in your book if you haven't done it already. And I'm going to talk you through this PowerPoint today. So we are looking more at the reasoning, problem side and the varied fluency side of things today. So by that, I mean that you can show me that you understand translation by applying it in some different ways. So if we just move through, we can see that we're talking about moving them on coordinates today. So if you can see that that blue circle on the screen is at the coordinate 1, 5. Now, if I just stop sharing just for one moment and bring my trusty board back round, remember, I just want to show you, I'm hoping you can see in this little space here. Remember on our axes, can you see that? This is the x-axis, this is the y-axis, and you need to read the x first, then the y. When we do our coordinates, they're in our brackets. We've done this during home learning. So you read the x-axis first, followed by the y-axis. Okay, it's really important that you remember that. Otherwise, you're not going to get some of these questions right today. So bearing that in mind, what I need you to do is read this coordinate. So 1, 5. So it says translate the point 5 right. 1, 2, 3, 4, 5. So you're staying on the same line. You are staying on the same line for that. And then you're going down 4. 1, 2, 3, 4 to see where it ends up. Can you tell me what that coordinate would be? That's right. It would be 6, 1. So if we carry on and we move down, you can see before and after. All right, so it's just changed the dot, the colour, just to show you. So we can look at translating the whole shape. Now to do that, you have got to actually translate each point before you join it up. All right, so you need to translate each point along the directions that it's giving. For example, translate the shape 3 left and 1 up. So A would have to go 1, 2, 3. And then I would put a dot there or a cross and label it A. Then C would go, an A and 1 up there. Then C would go 1, 2, 3 and 1 up. Put your circle or your dot and label it C. Join those two. Then B, 1, 2, 3 and 1 up. Now if you look at it now, you can see how the coordinates have changed. And that's translating. I haven't changed the shape of the shape. I haven't changed how it looks on the grid, so it hasn't been turned, it hasn't been moved upside down, it's just been moved across and up, which is what you need to do on the questions that you get given. This one's saying, can you describe the translation? So can you write it? So can you have a go on your whiteboard for me? What did you say? Am I right? If I said you go up 2 and across 2 and down 6, would that be right? No. Why not? That's right. You've got to go the quickest route. Now that could be one of two. You could say that point A has gone left 2, down 3. Or you could say it's gone down 3 and left 2. That's 2 ways that you could say it. Which way? Why do you think, though, I would use the one that's come up on the board. That's right, because we're reading on the x-axis first. So x-axis, y-axis. Left to right is the x-axis, up and down is the y-axis. So we would go with 1, 2, and then down. Well done. So this one is a problem-solving question. It's saying move one point to create a square and then describe the translation of that point. So if I joined all those points up, I would make a quadrilateral, but I wouldn't make a square because it's not right. The sides aren't all equal length. Where do you think the point needs to move? Which point do you think needs to move? Have a think. So if I was to draw a line. Oh, what's going wrong there? What's going wrong there? That's right, well done. Point B needs to move. So where does point B need to move to? It does, well done. It needs to be in line with point C on the x-axis. And then it needs to be in line with point A on the y-axis. So we're going to move B to here. And we would say it's gone one left and one down. Okay, well done if you got that right at home. That's super. You're working really, really hard. So now, points are placed on the following coordinates. This is a reasoning problem. So points are made on the following coordinates. So if I was to draw a grid, now I know you can't see this at the moment. 2, 4, 6, 2, 4, 6. So if there was a point at 6, 6, I'm just going to put it on. There was one at 4, 5, and there was one at 8. Oh. There was one at 8, 3. Okay. It says each of the points is translated the same way. The coordinates now are at 7, 3, 5, 2, and 9, 0. How are the points translated? Can you prove it? So I'm just going to stop sharing my screen. So if you can look at my board, you can see that I quickly drew the original points. Now, I did it ever so quickly. So you can see that the first one is at 6, 5, like it said. 1, 2, 4, sorry, 6, 6. So 6, 6. The second point was at 4, 5, and the third one was at 8, 3. And they've all been translated. So which points moved where? That's what it's asking you to do. So this one has gone and then down. This one has gone across and down, and this one has gone across and down. Now the question was saying they've all been translated in the same way. Prove it. Well, doing this, what I've just done is proving it, because you can see that they've all gone right 1 and down 3. Okay, so this shows that they have all moved in the same way. And that, remember, is what we want when we're asking you to prove something or asking you to explain how you know That is what we want, not just I know or because it did. You need to use the maths behind it. And if sometimes that is showing a diagram, that's fine. So you would just need to answer this question. You would just need to say they all went right 1, down 3. And then you could draw the diagram to prove it. Especially helpful if you're not as confident writing the sentences. All right, so there you go, you can see. So reasoning 2, the point was moved 1 right and 2 up. Greg thinks the original coordinates were 4, 4. Is he correct? Prove it. So you've got to work backwards. So if it went 1 right, you need to go 1 left. And if it went 2 up, you need to go 2 down. So that would put me there at 2, 0. So again, you could draw the diagram to prove it. Greg is incorrect because you need to reverse the translation. So these answers that you're seeing on the screen now in red, this is what we're hoping to get you doing. All right, we've been building on it all year. You've got to be able to discuss that maths. So circles, complete worksheet 1 and 2, and then choose an extension question. So you're going to do the questions 1A, 2A, and 3A. So this one. So you'll do 1A, 2A, 3A, and then this one. Oh, no, not that one, sorry. And then this one. 1A, 2A, 3A. All right. And then the extension is this one, and you can choose one of these questions. All right. Squares and pentagons, worksheet 1 and 2, and then an extension question, but you're going to do the 4A, 5A, and 6A. So they're the ones that are down on the next page, 4A, 5A, and 6A. Cut them out one at a time, stick them in your book as you would normally do. And then again, the same on there. And then hexagons, you're going to do 7A, 8A, and 9A. If you don't get on to the extension, that's fine. You don't have to do it. Just do the best you can. And really think about those answers and using these ideas to prove it with. All right, so good luck. Have a lovely last maths lesson. Have a fabulous half-term break. And I will see you on the other side. Take care. Bye-bye.